In this video, we're going to discuss how to calculate variance. Okay, so once you know how to calculate standard deviation, calculating variance is a breeze. Right? So the equation for population variance, so it's sigma. Remember, sigma is population standard deviation, right? So sigma squared, this is population variance. All right, so that's the notation for it, sigma squared. Well, guess what? Sigma squared is the square of sigma, right? So if you calculate the population standard deviation, if you square that number, you'll get the population variance, right? So sigma squared, the equation for it, is basically the equation of population standard deviation without the square root sign, all right? So it looks like this. Right? So if you had the square root sign and then you squared it, they would cancel each other anyway. So this is what population variance is. Now for sample variance, S squared is the notation that we use. This means sample variance. All right, so the variance from a sample. And S squared is, of course, the sample standard deviation squared. And you could also write the equation like this, the sum of the squared differences from the sample mean divided by n minus 1. So you don't have the square root because it cancels with the square. All right. So in the previous video, we calculated the sample standard deviation for this data set. So in the previous video, we calculated the sample standard deviation to be 2.26. All right, let's scroll up so I can double check that. Yeah, this is the previous video, 2.26. All right, so now when I'm calculating the sample variance, I will just square 2.26. Let's go ahead and get out our calculator. 2.26 and I have to take this square is 5.11. All right, so 2.26 squared is 5.11. All right. The main disadvantage of using variance is that the unit is now also squared, right? So this was the number of phone calls made per day. So now this is the unit for, the sample variance is the number of phone calls made per day squared, which doesn't really make much sense, which is why we use standard deviation more than we use variance. Though otherwise, sample standard deviation and sample variance have very similar properties.